Good afternoon.
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 Hey guys, how are you doing?
Pretty good.
Hey, quick check. Did you all get a link to the Word document that Rama shared? I sent a notification. I did not seem to get it, but I sent it again for that reason today. It should be from groups.io, the hardware fault management message. Did anyone get it?
I'm looking.
I resent just now as a special message because last time I did not check the box and I did not get it. So I don't know what happened.
Groups.io. Don't see it. Does anyone else?
Is it the GPU accelerator
Yes.
RAS? Yeah, I got that.
Yes. Yeah, but you got just one just now, right? Like a couple of minutes ago.
Yeah, just now.
Yeah, I sent one like a couple of days ago, but I do not know what mistake I made in
Oh,
sending
I
that.
got it. I got both of them. I just am so
No, I
drowned
got-
in
Oh, you got both of them. Okay. Okay, good then. I don't know. It must be my mailbox. I somehow missed it.
I got that one. I got that one. That
Cool.
one. I got both of them.
Okay, so yeah, that's the document where folks can, leave their comments. And just for quick reference, I'll also paste the whole message here in the chat window, so people can right away see it. Yeah. So this is for GPU RAS and accelerators feedback. Yeah, Rama, that's the document. I'm talking on your behalf.
No, thank you. Really appreciate it. I joined few minutes late.
No, thank you. I was just making sure people got it so they can leave comments in there.
Yeah. And just a quick thing. I think there is some good feedback last time about the security of error injection. We are discussing. We will be updating that spec and then for that portion. Okay. As part of next spec release. Okay. If there is any other feedback, we'll be looking forward to it. We want to further improve based on the more feedback. Yeah, thank you. All the teams.
Now, another, thank you for that, Rama. I'm sure there's this whole aspect of being able to randomly pick a machine which is in the production fleet and inject to it is completely, it will have a lot of conflict with the security requirements that we have. So yeah, that's going to be a tough challenge to find. We somehow need to find a balance. So thank you for that, and I think you'll get a lot more feedback now. Now, another agenda item for today was Anil Agrawal, who has been collaborating at our request with the Cloud Service Model Future Technologies Initiative Cloud Service Model project. Is working with George Kola, and they do have a session in the Global Summit, and Anil wanted to review that today. So I do not know where he is though. He just gave me access to the document. While we're waiting for him, are there any other opens today?
Doesn't sound like it. I still need to work on the table of air injection stuff, and I just have been swamped. So I'll get to it. But I saw that Mark or that Anil had something, so I didn't sweat it.
Hey, Drew and Yogesh, one unrelated quick question, but for the upcoming OCP summit, Tony and I have been working on a little statement from Micron for the FMFM
Awesome.
portion of it. Do you just want us to email that to you, or you want us to put it directly in a deck somewhere?
Either way is fine.
Okay.
Iman, and email is
so-
probably better. We can go back and
Okay.
forth. Either way is fine though.
Sounds good. Thanks, Yogesh. We looked for the deck and couldn't find it on the OCP site, so we figured we'd just email it to you.
It's on the work in progress, I think. There's a work in progress folder, and under that there's a Global Summit folder for 2023.
Yeah, I think at this point though, Drew, we already submitted a draft version, which
Yeah,
may
so-
not be the exact same version that's in work in
True.
progress. So
Well, that was supposed to be an 80% version, so we can change it for sure, right? And
okay, yeah. No, just to make sure that we get it. I think
yeah, sounds good. Thank you, Evan.
we may not be looking at the work in progress folder version. That's what I meant to say.
Yeah.
All right.
Whoa.
So
Well, I'll email it to you then.
yeah, very well then. Thank you.
All right,
And
thanks, guys.
Anil, I see you are here. So
Yes, I completely forgot that we have switched over to Zoom now. So I was on the other meeting. My bad. Sorry.
I did send a new calendar invite. If you delete this one and import this new invite from, I think you probably had to do it from groups.io. There's a method to do it. I thought I sent an email about that to Vilas and others also, how to, because I had the same problem. I could not change it in the Outlook. And so I resent the calendar invite with the Zoom link. So you might want to do that.
Okay, sure. I'll do it.
Yeah,
Hey,
the recent link worked. Nothing else could work.
Yeah, and is it on the wiki? I think maybe we should do is find the wiki page that has our group, and
That'll be
and
awesome.
then if it's on the wiki, then maybe that would we just paste that in the chat here, and everyone can click.
I think yeah, we can do that, but really groups.io is where most of the communication is taking place. And that link, groups.io, is in the invite to the link to that, right? That's where you can see the calendar and directly join from there and see all the messages and not.
Okay.
I think before we start that topic, Yogesh, I think last week there was Anil and Vilas were asking for Word document. Hopefully you get to see we uploaded to that OCP. Really appreciate your feedback and thank you, Anil, for last week feedback. We are discussing how to further improve on that session. Just want to. Okay. You get sent the email also. Yeah.
Yeah, I saw your message. I haven't gone to the link yet.
Okay. Yeah. Please do provide comments and yeah. Thank you.
You just sent it today, right?
Sorry.
You just sent the link today, right?
Like 4 days back.
So there's one today also. And there are two messages I sent again today, but I think folks have confirmed they received both the messages. One that was sent a couple of days ago also.
Cool. Thank you.
One thing I think to stay on top of whatever is going on, I think I'll post I'll dump the links in the chat window again. So, please join and subscribe to the group mails. That's our main mode of communication here. So please use that. Join the mailing list. All right, Daniel, all yours.
Oh, am I next on the agenda?
You were first. We're waiting for you.
Oh, my bad. Sorry.
No,
Okay,
no, it's
I am. Okay, let me share my screen. Okay, I think George is not on the call, right? He might not have meeting invite. Okay, so I will talk on behalf of George. My objective right now is not to kind of walk through each and every slide, but want to share the thought process and the content and get feedback from this team. If the scope of this presentation and the thought process is looking good, or do we need to make some changes? Right now, this is still a draft. And so this presentation is part of the CSM track. I don't know which day this is going to be opening, but it's first day or second day, I'm not sure. So the topic is demystifying in-band, out-of-band methods for hyperscale fleet management. So George from Google and myself, we have signed up. So I guess, I mean, the contribution is going to come from all of us. So the overall outline is we want to define the hardware management scope. Just to kind of clarify the focus of this discussion and what is not focus of the discussion. And then clarify in-band, out-of-band management methods. And then we are thinking to kind of, between two of us, queue up two questions, you know, like I will ask about Google Cloud that George will answer, and then George will ask two questions about the Meta Cloud, infrastructure, and I'll try to answer those. And then the remaining roughly 10 minutes or so, we will open up for audience Q&A. That's the thought process here. So slightly different from typical presentation. We will just, you know, present the slides and then open up a question. Yeah, Q&A. And this is not a panel also, because we will have some slides and we will discuss concepts and then we'll open for a panel. So from the hardware management scope, this is still work in progress. I got some more feedback this morning, and I'm waiting for John to share a few slides. So the scope what we are defining here is two main areas: system monitoring and hardware fault management. System monitoring like firmware versions, device inventory, sensors, and fault management is any kind of error that are being detected, logged, and signaled. How do we manage those? There are a bunch of other capabilities or areas covered through hardware management, like firmware upgrade, downgrade, and this is where I would like to kind of add a bunch of other things that are within the hardware management scope, but we will just not discuss that, otherwise the whole discussion will go all over the place. So we want to kind of focus on just two areas as an example.
Excuse me, so someone needs to mute. I'm hearing a lot of background noise. If you're not speaking, please, can you please mute?
Are you able to hear me?
Is it you, Rama, that needs to mute? I see everyone else is muted.
Oh, let me check. I muted. I thought I muted.
Thank you. Sorry about that.
Yeah. And how is my voice? Are you able to hear me?
Yeah, we can hear you fine, Neil.
Okay, perfect.
You're clear.
Perfect. Okay. So with that thought process, next we want to zoom in onto system monitoring. And so this is the slide that George and Panos put together. I think maybe other folks also put together. So what we're showing here is a host with an in-band management agent, and as well as out-of-band the BMC agent. And how the information flows from a given host or fleet of hosts to a CSP's tooling infrastructure, where the events are aggregated, and then eventually some type of aggregation at different levels happens, and then the data is stored, and some level of component filtering happens, and then checked against some template. And if there is a mismatch, so for example, if there is a, let's say, firmware versions are being monitored, and if we find a given firmware version is not matching with what we expect, let's say NIC firmware, then there'll be a remediation kicked in where the machine will be taken out of service, firmware upgrade will happen, and then the machine will go back into production. So this can be implemented in band by monitoring through this in-band agent, or could be monitored through BMC also. Now, there are cases where BMC may not work, especially if we want to, say, upgrade the firmware and a device doesn't have a direct access, or BMC doesn't have a direct access to BMC, that's to the device. In that case, there will be an assistance required through the in-band agent to upgrade the firmware. So key message here is that there is no one type of solution fits everything. We have to rely on a combination of in-band versus as well as out-band.
Hey, Bilal or Anil, I have a quick question for you. So,
Yeah.
so when I think what you're saying makes sense. Like for instance, if you're trying to monitor how full the disk is, right? The OS owns that. You can't do that bare metal. The OS is the only thing that has a notion for when you think about a disk. So is that the argument? And then you could put like the disk full statistics out the BMC somehow with your proposal?
Yeah, I mean, again, here we are not doing any proposal. We are trying to clarify what does the in-band versus out-of-band really means, which maybe some of the audience may not be knowing. For us, we know, right? So we want to kind of demystify that and clarify, provide the key message that there is no single solution, in-band versus out-of-band, works for every such scenario. We have to rely on both type of implementations based on our needs. So what
And
example
it boils down to based on what you want to monitor, right? Like
exactly.
And so like, and I'm sorry, I'm not trying to be hard. I'm just trying to make sure I understand you. So I just want to be super careful to understand you. So if it's like error logs from hardware, we want to get those out of band, and there's no reason we shouldn't be able to do it. But if it's something that's OS visible, or is maybe even higher level in the software stack, that seems like it would have to come in band somehow to out of band. Is that what you're saying?
Yes, that's one good example. The example that I gave, Drew, firmware monitoring, right? Firmware version monitoring. So firmware version monitoring can be done either way. However, if you want to upgrade the firmware, let's say we find a deviation and we want to upgrade the firmware, and if the out-of-band method, BMC method, let's say BMC doesn't have direct access to the device to upgrade the firmware, then we have to rely on an in-band agent. Even though the request may still come through, from our tooling to the BMC, but actually firmware upgrade will happen through in-band agent. So that's where this whole thing becomes a bit dicey. And we want to demystify that. Hey, there's nothing like a pure in-band. There's no pure out-of-band.
Well, but here's what I would say, and Neil, if in-band was really important, if out-of-band was really important to you and you wanted to be able to manage everything possible out-of-band, you could design software updates that work out-of-band for whatever you're supporting. And so that's why I was looking for a use case that was clearly 100% impossible to do out-of-band. And that's why I went to disk space, is because the BMC doesn't own that, the OS does.
Yeah, that's a very good point. There's some architecturally, well, I mean, you can always design that way. Do that. You can, have a communication path to BMC, and then we can implement to BMC as well, right?
So, but you need in-band support in that case. So that's what I'm trying to really make a crisp distinction on, is that if you do disk space out the BMC, you have something in the OS helping you. But if you can design firmware update to work entirely out of band if you own the system and own everything in it and can control it. Or you might be able to drive your suppliers to enable your out of band path if you're patient.
Well, again, that depends. If my design is cost efficient and I don't want to really implement a high bandwidth interface, let's say a NIC to BMC. So if I want to upgrade the firmware from the BMC, I don't have a direct path.
But Anil, again, that is a design decision that you've
Correct.
elected not to support firmware out of band. But the firmware can be done out of band. That's why I don't like the example. I prefer the OS example because the OS example requires in-band support, where the firmware is a system design choice. You looked at some trade-off and decided you didn't want to drive firmware updates fully out of band.
Correct. You're right. So either a design choice or by architecture. There will be cases where we have to come up with a solution that relies on both in-band and out-of-band.
And I agree with that. I'm just trying to draw the distinction out that I'm trying to affirm what you're saying, but just it's a different example because I think your example is a design choice. That's all. I agree with you.
The entities that only the in-band understands, right? Whether it's volume or a virtual machine, right? So you can't manage a virtual machine to out of band at all.
Exactly. So I just want to pick an example that's clearer, and that's
a very good, yeah. And maybe you're right. Maybe we want to use that example, which is a lot more crisp and uniquely identified. The other one, Drew, I know we have now defined we have defined the requirements, and hopefully we can implement also is OS page offline, which is actually not really fitting in this bucket here. I mean, on this slide, because this is purely about monitoring of not the error events, but non-error events. But just as extending the thought process, where we can give another example where there's a very unique differentiation of in-band versus out-of-band is, let's say there's a page offline is required.
Well, and that's again, might be a design choice, but I think what we could generalize it to is RAS actions that require OS intervention require the OS to support the RAS action. So you have to get the message to the OS. And I'm not trying to be contrary, Neil. I'm actually trying to support you. If you make your issues unequivocal, that they are super crisp and undebatable, then people will click to your way of thinking faster. So again, I'm not trying to push back. I'm actually trying to support you.
Yeah. That's good. And just FYI, Drew, I asked George to reach out to you and maybe a few other folks to.
Yeah, we're meeting Monday. Thank you.
Yeah, to get more input and crisp our content as well and talking points. So,
and by the way, Rama, I'm so sorry, but Rama has had his hand up for a while, and so I'm sorry, Anil, I'm being a pain.
Yeah, no, thank you. Anil, like just one more question. Like there are also, I know you mentioned this is like education clarification because some people may have. They're also working on some contributions, right? Is this the contributions also part of this talk, or is it only for education kind of?
It's not the primary objective of this talk.
Okay.
The primary objective is, as the title is, demystifying in-band versus out-of-band.
Okay.
But in the discussion toward the summary, right, we do want to clarify, okay, so fine, we learned everything. We learned about in-band, out-of-band, what are we doing, right? So in that context, we will definitely clarify both activities, in-band management architecture white paper contribution that we are still working on, as well as the work that we are doing here for out-of-band, right? We need to and we are also clarifying the area that we still need to work on. That is Still open.
Yeah. I think want to add on to like some events, even like Microsoft environment, like even though we are pushing many things to out of band, like some events, disk events or some RAS, like error resiliency, like say EDPC, those things are still in band. I think, yeah, maybe some people have confusion of that. I think we are aligned with the message. There is a need for both. It depends on the scenario and all, like how much we are pushing for like RAS fault management out of band. That is the other story. Yeah, thank you.
Correct. I think you said it very nicely.
Yeah.
We have to, depending upon situation, scenarios, we have to be open and rely on both kind of methods. And so that's the kind of key thing we want to clarify here. First of all, differentiate what in-band means, what out-of-band means, and then how both are relevant for.
Anil, one thing that would be useful in this presentation is, do you remember in the document, for the requirements document, you came up, it was your thing, you came up with use cases like, I forget what it was, application providers, or, you had the different categories in the requirements doc. It might be useful to map some of those use cases to in-band, out-of-band here, because I thought the categories you came up with were useful. They helped us. They helped us as a group make progress. I presume that they would help other people make progress as well.
Yeah, that's a good point. Let me take a look at it. Maybe we'll put in the beginning itself, right? Kind of framing the problem statement. Yeah.
Yeah.
Mm-hmm. Yeah.
And again, I hope I'm not being too picky. I really, I am trying to help.
Yeah, absolutely. So any feedback is good feedback, right? Because this is our presentation, right? Our collective efforts that we are communicating broadly. So we want to be fully aligned, right? So okay, so this is a system monitoring example. Then the next slide, we want to talk about the hardware fault management. And I have a sort of animation here, like these 3 callouts comes in the second click. So first thing is, when it comes to fault management, the error events as they occur flow from the hardware through the firmware, which is vendor specific, to either straight to the kernel or through an in-band firmware. This could be another core having a firmware as well, as long as it is some standardized way of communicating to the kernel. And then the other path is through the BMC. And eventually the information, if it's an in-band, it could be either OS first going straight to OS, or firmware first going to the firmware. And then once we get to the kernel OS drivers, then of course in some fault scenario the application will get impacted and all that. But then there's the DC tooling. This is the in-band management agent that we looked at in the previous slide. That then eventually talks to the DC infrastructure, the other part of the box we were showing earlier. And likewise, if it's an out of band, then there's a direct path, or indirect path, but still logically direct path to the BMC to collect the error events and then communicate the RAS actions. Now, when there is an out-of-band methods, so this is the out-of-band method you can call, and this is the in-band method. And within in-band, there are either OS first or firmware first. And in a given machine, given system, given cloud service deployment, we may deploy any of these combinations, depending upon the fault scenarios and fault events. So there's no single type of implementation works for all type of events. Practically not possible.
So Anil, sorry, Andrew, a real quick clarification on DC tooling. I'm not sure if I fully comprehend what is meant by DC tooling. Is it in-band only agent cannot be accessed out of band?
Yeah, so DC tooling, I'm using a very loose term here. There are agents that run on the host, and there are agent runs in the infrastructure. They talk to each other.
I think that would be good to clarify because that is really confusing. I think, can't you call it a FMGT agent or something? I mean, the word agent is.
Yeah, so this is the agent. That's what I said here. Sorry. Yeah. So the DC tooling, maybe I should just leave it IMA. How about that?
Yeah.
Right. So I mean, in our lingo, we call tooling DC tooling. But just to be consistent, I'll just use IMA because that's essentially what I'm showing here. This IMA box is what I'm showing here. And this IMA talks to the DC infra, just like over here, aggregator and all that, right? And the auto remediation that again, in our case, we have this auto remediation runs through IMA and through BMC as well, depending on scenario. So it gets really kind of, we use both basically. There's no single solution that fits for everything.
So you do want to go ahead, Drew, you go ahead.
So Neil, I want to be really careful there. I believe that we are heading to we're driving to a point where we can do some things completely out of band. We can't do everything, but we can, for some use cases, we can support them out of band. And so I want to make sure that statement's nuanced. And the other thing I don't really understand here is I see your tables upside down. My experience is that OS first error logging means the OS grabs the machine check bank registers. And if you're lucky, maybe a few other registers and that's it. And then what we've done in firmware first is richer. And like if you look at crash dumps or AMD's ADDC feature, that is like vastly richer. And then if we look at what we're doing with the full out of band solution, it's starting much richer than what the OS collects today. So I think it goes richer the further you go away from relying on a generic kernel to log things.
Yeah, that was my question too.
Are you referring to this table where?
No, in your diagram, Anil, it seems like
the table too.
IMA.
The table. I'm talking about high fidelity and low fidelity. I think that term puzzles me some. I think.
Yeah, let me clarify. Yeah, let me clarify. I see your point. Let me clarify. If you look at any machine, right, the probability of a correctable error is much higher than uncorrected. Do we agree?
Sure. Yeah. Much higher.
Right. So the first order of action or sort of methods is to manage these correctable errors. And in the case of uncorrected error, the likelihood machine might crash unless there's a recovery conflict. And so that's the one thing that I want to clarify. High fidelity is there are order of magnitude higher rate of errors.
Yeah, I just don't see any data that validates your assertion. In fact, I have quite a bit of data that counters it.
What counter what?
You don't. So the value you get in memory error logging is not sheer quantity, it's quality. If you get a good representative sample, that is sufficient. It's more important to get the right registers than it is to get a million error logs without any details about which bits were flipped.
So what you're saying is correct. And again, you're talking about the patterns-based method, right? Which can be done through form tables, right? And that is correct. But before you get to the pattern, if there are correctable errors, that rate is still going to be high. And you're absolutely right that you may not see even a single bit error, and suddenly you will see a pattern and machine crashes, right? Is that what you're referring to?
But we also see low rates of corrected errors too.
Yeah.
So I think I guess what I'm disagreeing with, I don't understand the fidelity thing. I think if you said higher, can handle error rates faster, I might believe you, but I don't really think that that's all that valuable.
Yeah, our experience in our fleet, considering let's say PCI error, cache errors, PCI errors is a very classic example where, and I have tons of data for last at least 5 years.
Anil, maybe I need to understand what you mean exactly by fidelity here. I didn't grab the concept of fidelity actually.
Yeah, high rate of errors.
Why don't you say high frequency?
Frequency is what you want to say? Why
Yeah,
is
high
fidelity?
fidelity is yeah, maybe this fidelity term is yeah.
But fidelity is a very troublesome term because I don't
Yeah.
think frequency equals quantity or quality. Or you know, if frequency does not imply quality to me. It's really what you want is good error logs that help you understand what's going on.
And so that aligns here, right? So like a pattern type concept, which is not related to rate, could be low rate, right? And we do want to rely on firmware-based methods in that case.
Yeah. But I guess the trouble I'm having is that you're implying implicitly through this is that InBand is somehow superior. And I don't see that that's the case because my experience with InBand error logging is that you can't always get all the registers you want.
Yeah, so if that's a message here, then that is not correct. There is no priority in these three cases. And that's maybe one of the things I want to clarify to the audience that, look, there is no single solution, single type of failure, which is most important. They all are relevant, and we need to build a solution that covers all of them.
Well, and like for instance, out of band, you kind of I'm talking about, you know, autonomous crash dumps or AMD's ADDC feature. You know, there you're not really running software anymore. You're done because the CPU's dead and hung. So you have to do that out of band if you want to get it, or I guess reboot. But you know, you may not be able to reboot. There's some cases where you just need to log it because your CPU died hard.
Yeah. And so that's a good point. Let me make sure that I clarify here in this one, right, sir? Because I want to.
Thank you. You'll make me calm down if you try. If I don't see that you're like, if you're saying that InBand is superior, well, it's better at some things, but it's not just patently superior. Out of band is better at some things. InBand's better at other things.
Yeah.
And I think we agree. We just got to make sure the slide indicates that.
Yeah. So tell me what, maybe offline, give me comment, suggestion that will make that very crisp. Because that's
okay. I'll work with George on that because we're going to go over this again probably on Monday, and then we'll give you feedback. But if you could make sure you send the slide deck to him, that would help. Like, you know, any changes you make here.
Yeah, it is already synced.
So it's a cool. I wish we had done ours that way. Okay.
Second.
So go ahead, Drew.
No, I was just making a joke, but I had to get a copy. I had to buy a copy of PowerPoint.
No, this is Google Slides, right? So they are synced. So the link that I sent, right?
Rama says thank you, Drew.
Sorry, I'm not trying to badmouth you, Rama, but I just I like working online.
Okay, I think in interest of time, maybe
one quick observation here, Anil.
Yeah.
This slide and previous slide, the organizationally the placement of IMA. In the previous slide, are you implying the only path to IMA is through OS or driver?
Yeah.
Well, it is an OS agent, right?
Yeah, exactly.
Okay.
That's what it is. It's basically, and that's the problem, right? Is it's great if you're in an environment where you can load an agent on the OS reliably, then it's super handy because you can monitor things that only the OS can see. So in some use cases, and that's where I'm going back to your slides, your categories, Anil. You have a bare metal machine. You can't reliably load an agent, and so you need a more complete out-of-band solution. And so that it is definitely host-based.
Yeah, and again, for out-of-band, what I intend to say here is that maybe I should change it. So high rate error handling can be implemented. It just has its own complexity, and that's essentially I'm kind of leading to that point that we are working through our group to define the requirements and the interface specifications so that this out-of-band methods can also be implemented.
Okay.
That's the complexity that you are thinking, Anil. You want to convey in your presentation on the out-of-band?
Yeah, good point. Yeah, so when we build out-of-band methods, right, there are several fault scenarios where there is a OS ownership or OS communication to the OS and driver communication is required. So we need to build this additional interface from BMC to the host to communicate that. For example, page offline.
I see.
Right. So which really doesn't exist, or I would say there's no really, these are proprietary solutions are implemented so far. We have done it. And vice versa, let's say we are monitoring, let's say memory corrector, we are monitoring, let's say through invent method. And we have reached the point where our tooling, our algorithm says, yeah, there is now time to do a dim swap through action. Now, we can't just rely on our invent agent because, as Drew was saying, this OS can crash anytime. So what we want to do is save it into persistent store in the BMC flash. For that, we need a pipeline to get to the BMC.
Okay. So I think really what you meant, instead of implementing, I mean, based on what you described, I think that the complexity is not really in implementing the high rate errors, but it is in handling the high rate errors, right?
That is correct.
Okay.
That's correct. Yep. Yeah. So hardware fault management includes, monitoring the errors as well as processing the errors and then taking the RAF action. And gets a bit complex, and that's what through our team we've been working on with Drew's leadership on the requirements. Yeah. And now through the vendors, the implementation will happen. Will take 1 or 2 generations, which is, I mean, I'm glad that our vendors are listening and working on building a solution. Okay, so for hardware fault management, I want to give one example as well. This is the example where I'm taking it from one of the system cluster that we have built, where we have a bunch of accelerators, OM, and the PCI switch and the CPU. So in this example, let's say the OM, which is the accelerator module, detects a PCI completion timeout due to a delay in response from the OCP.
Now, in this, Anil, I think OAM is a little bit weird. People, if someone's reading that, oh, I see, it's an OCP accelerator module. Okay. Yeah. I'm sorry. I see that you define it, but that, I look at that. Oh, that's Greek to me. I don't know anyone that really calls it that in real life.
Okay. Yeah, I can say accelerator module here. Is that OM is an OCP term. OCP has defined it.
I know. Okay, I'll shut up. I was just saying PCI device detects, PCI completion timeout, but
anyway. Sure, I get fixed. Not a problem. Yeah. So I mean,
and it may not be an OCP device anyway. It could just be a NIC. I mean, right? It could be anything.
Yeah. I'm just giving a precise example, something more realistic, right? And walk through and clarify how just one type of method is not sufficient for such a implementation, and we need to rely on both in and out of band. So in this example, although the error was detected at the device, but the real failure actually is on the CPU side. So it gets a little bit complex to find the proof where the real action is required. Because if you just replace the GPU, it's not going to, the PCI device is not going to help, right? And the failure will again come back. So these are kind of things when we have a large fleet, right, becomes very critical to understand the failure and develop the solution for through action, which is much more precise. Otherwise, we'll be going through the repair endlessly. So in this example, when it comes to fault handling, right, we are really using an in-band firmware first, and we are using out-of-band also. So where we do use invent, in this case, example, when it comes to because this is an uncorrected error, the comes to timeout, the containment is required. And the containment is all implemented through in-band hardware firmware OS. BMC is not involved here. This is not out of band at all. And error, sorry.
So one thing that puzzles me here, Neil, and I'm so sorry, but what I don't understand is, for me, firmware first equals SMM. And yes, well, I mean, on ARM you have other things. You have EL3
Correct.
and you have microcontrollers, but those EL3 and microcontrollers usually work together to support rich out-of-band error logging on ARM, and so I would say that that out-of-band would be firmware first too. I mean, the firmware first is closer to out-of-band. We're like when I worked at a previous company, and we were trying to deal with random OSs that customers might load on our machines. Firmware first allowed us to send error logs to the BMC and process them. It was approximating out-of-band, and as we moved to out-of-band, I believe that the line between firmware first and out-of-band is going to become blurry.
Yeah, you're absolutely right. That's why I'm giving very precise example where this is how we implement it. It could be implemented slightly differently also. Where
but in the fault handling bullet, you've grouped in-band firmware first and out-of-band, and if you said in-band comma firmware first and out-of-band, but it's really in-band and firmware first / out-of-band, because the two, I think, blur. Those two are closer together.
Okay, I see. So you're saying that let's keep it in-band only, right?
In-band here, and then if you say firmware first / out-of-band, because what we're trying to do in out-of-band is make it look like what we do with firmware first without SMI on x86.
Yeah. So I think let's keep it simple, right? In-band and out-of-band methods, right?
Okay, sure. That sounds good. Again, I'm not trying to be hard. It's a puzzling thing because firmware first and out-of-band are supposed to be really close.
Yeah, and that actually you're hitting a very good point, right? And that's where we are trying to, with the illustration, clarify that in this case, in this specific example, when we are doing in-band, we are using firmware first method. But this is not the only way to implement. It could have been in-band through some sort of a path. It'll be vendor-specific firmware to the BMC as well.
Yeah. Well, I mean, we've done code where we have the SMM drop off a CPR log for the BMC to come pick up later, right? So we've approximated out of band with SMM.
Yeah. But I think the in-band definition is pretty clear, right? If your firmware is running on the course from your SoC, it's in-band. If it's not, then it's out of band, right?
Correct. So
it doesn't have to be SMM, right? It is regardless of SMM. You can run SMM code or you can run ASL code. In your in-band, it's still in-band because you're using the course in this.
So that doesn't match my definition, Antonio. My definition is in-band is OS, firmware first is its own thing, and then out-of-band is something else. So I don't know. Maybe I'm just off in the weeds here, but
no, you're thinking in the right direction, Drew. That, and this is the reason I thought of putting together this presentation to at least open up the discussion.
To demystify it. You're absolutely right on that part. I think it's useful. Yeah, I like the goal.
Right, and I think what you're referring, Drew, is from the error reporting point of view, right? Error reporting could be a combination of in-band and out-of-band. And,
yeah.
Right, which is true. This is exactly what we're doing here. But the containment, this containment flow, right? This is strictly in-band.
Well, containment, that's not entirely true. I can create a containment strategy that relies only on the firmware.
Only on the firmware.
Yeah.
Yeah, firmware. Yeah, so in-band basically.
Right. But I guess the way it's written here implies that the OS and the OS may or may not play. So like Well, I guess I take that. I take it back. I'm going to shut up because I see your point. Like I could have a really negligent OS that got a machine check and said, yeah, whatever, we'll just resume and keep going. So in that case, your OS destroys containment. I'm going to shut up. I think you got it right. Sorry, I just had to think it through. You're right.
Yeah.
You're right. Sorry.
Yeah, I mean, I'm looking at the DPC flow here, by the way, and in the case of DPC, right? We want to make sure that the drivers are quiesced, and that's where the OS, the driver.
Well, that's for recovery, isn't it? I mean, containment with DPC, you shoot the PCIe link, contain poison egress, and at this point, if you do nothing, the OS is probably going to crash. But that's okay.
No, it's not okay.
You it without OS help.
No,
I'm talking in terms about preventing SDC.
Yeah, we want to make sure driver is quiesced. That's how the DPC architecture is. That's the right way to do it, containment. If you let the driver run, that's not containment. That's not a complete containment. It's like same as surprising down, right?
Let me make sure I understand. When I've worked on this in the past, and I'm still experiencing this today. This is very fresh in my last week and fresh in my memory, and I'm finding that we can't trust every vendor to do the right thing when a poison TLP comes their way. And so, but if I shoot the link before and the poison never gets to them, I contain the error. Now, whether or not their driver cooperates and whether or not the OS, I've shot the link, and I'm probably that probably ends up shooting the OS, but I have contained the error.
Mm-hmm.
And then recovery, it's more graceful if the driver can recover, and if we don't have to bring the whole machine down, or maybe we shoot a virtual machine that was using that device. There are all sorts of more graceful things, but they don't.
So again, I think you're overlooking one thing, Drew. So you're right. If we can do a fatal NMI and crash the machine, then that's good enough. But what happens though is that's not the only way this error flow happens. Non-fatal error, for example. In that case, we will not do a fatal NMI, and kernel crash will not happen. And now the machine is in this limbo where driver is still doing something, and we're getting master board, but that's not guaranteed also, because driver is going to blindly keep requesting, doing something, and even causing all kind of other side effects. So we want to quiet the driver.
You're saying but when the PCI link goes down, you can configure the machine to crash.
Wow, that's a different problem then. That's a very hard way of handling.
It is. I know, but I'm only poking at this to crispen up our definition.
Yeah.
But that is the safest thing to do. If I'm a system vendor and I have to support 10 million PCIe cards, some random card someone plugs in, and I want to protect myself against SDC, I might set it up so that I shoot the link, and if they're smart enough to configure recovery correctly, maybe we let the link stay up somehow. But otherwise, the link goes down and we crash the machine. And we say, and normally if I go to an enterprise customer and say, hey, what do you prefer? Do you prefer an outage or do you prefer corrupt data? The answer is an outage.
Well, so I'm not going to say differently, but I'll just add something here too. That after crashing the machine, if I can't find the root, and this is a classic example that I'm giving a CTO. Okay, if I crash the machine and after rebooting machine, if I lose the error logs for whatever reason, I don't know what caused the crash. Yeah. So I need to be able to collect the log before I crash, and that's not that straightforward if I just do a hard crash. So my strategy will be to contain first, okay, quiet the driver, and then let my tooling come in, pull the data, and then reset the machine.
Oh, I mean, if you have SMM-driven error logging, you would take an SMM for the IOMCA or NMI, gather the error data, stuff it somewhere, and when you reboot, there'd be a log waiting.
Yeah, so stuff it somewhere is where we run into problems.
I wouldn't rely on that either.
Yes.
Right?
Oh, I agree, Mark. I mean, but ADDC or crash dumps seem to be a safe.
ADDC is a last resort, right? But that also is very painful to implement and get to the fru fast enough, right?
No,
So,
no, you hold off resets.
mhm.
I mean, if you do it right, you can do this completely out of band. So this is why and I'm so sorry if I'm boring everybody. My point is that we have an option to do something elegant using an in-band and out-of-band method. I can contrive an example where I get good SDC containment with a fully out-of-band solution. And so the advantage of the in-band solution in my mind is that by involving the OS in handling the failure, we have a chance at gathering more error data, maybe from the driver, and we have a chance at perhaps recovering if the driver is and the device are well implemented.
So Drew, I'm showing that here, right? So once the errors are captured, I mean, in this example, I'm doing it through this platform specific error handler. You can call SMM, right?
Okay.
Depending upon implementation. And then my DC tooling or infrastructure is actually pulling the data from the BMC. And that time BMC would have collected more data. And that's how I'm actually using that information to do the remediation. My remediation flow is not relying on in-band.
Got it. And maybe my problem is that I don't know what the numbers are doing. Okay. That's it. Thank you. That's helpful.
Number, I'll take it out. I pulled this picture from the other presentation that I would like to schedule maybe in next week if possible to talk about our AI ML cluster containment solution that we put together, and I'm going to be presenting that. So I pulled out right from there. So I will be discussing this whole flow in more glory details in that presentation.
Okay.
But maybe I can remove these numbers for this context here. Anyway, I think we are way, I think just 1 minute left here. So then it just is kind of summary of so challenges in using single method for hardware management, right? One shoe doesn't fit all. Benefits of using a hybrid approach are there. Now for out-of-band hardware fault management requirements, we are already working through. Currently, they are driven by hardware fault management sub-project.
So I think I'm going to keep. I think that if we talk about the use cases, that would really highlight the challenges and say, the single method may be required, for instance, for the bare metal because you don't have much choice. You don't have an agent. But if in the other cases you listed, there are advantages to doing in-band. I think if you could list that out, that would make that first bullet more meaningful.
Yeah, I think that's a good point. Let me think through that, and then maybe right in the beginning itself, I will make that clear.
Like, what are the challenges? Yeah, but this is. I think this would be super helpful to have and point people to it once you. I mean, like, I'm going to steal your deck. Good, if you can spell that out clearly, I will. I want to steal this and point people to it.
Sure. And then the last bullet here is the in-band hardware management requirements. So there's a white paper in progress. But then as far as the requirement and the associated specification, this is still need to be developed, driven through OCP. So
can it be one size fits all too, I guess is the question. I mean, here's an interesting thought. We might be able to do things like tie this to the RAS API and say, hey, we have a error logging path that we're building for you to plumb to this driver.
Yes, I think that's a good good way to bring the message home that because of this complexities, there's an initiative going on to define a RAS API to converge, to provide a converge solution where we provide the spec-defined, API-defined interfaces for CSPs to pick and choose and implement. We will still build a solution where we will use both methods depending upon the fault scenarios. We will probably never go to just one method alone.
Well, I guess I would put it this way.
When I say we means, again, I think you made a very good point that in the case a CSP owns the whole stack. That's what I meant to say we.
Oh,
So-
yeah. Okay. I think we need to clear, that's where my heartache with this presentation goes away. If you can clarify the different use cases and where they're used. Again, I know I'm a broken record, but then I would love this presentation because, I can point people to it and say, look, we're in the bare metal situation, so we've got to do this.
Mhm. Yeah. And the call to action, basically, engage with, I will still need to finish this up. But the message is to, engage through our CSP as well as hardware product management working groups. Sorry, 2 minutes passed. Yogesh, back to you.
No, not at all. This is good. Good discussion. So, yep, we are done for this week. So you have it out there. The link is in the chat window or in the email. I don't know. Everyone got the link to this talk if they want to leave any comments, Drew? Oh,
I was just clapping my hands.
Okay.
I think this is a valuable activity, and I really appreciate the work that you've done to align CSP with us, Anil. So I know I have a lot of comments, but it's just because I care. It's not because I'm critical.
Yeah, even CSM, right? Cloud service model. Yeah. I think that's good fruition of your efforts. So, yep, I attended your talk earlier in the day also. So yes. Do you want to share this link with the mailing list that we have, so I can just send it to everyone?
Yeah, I just added to the chat.
Okay.
And I think you have the link, Yogesh, and I already gave you access also. Maybe you want, because I don't know how to send product email to. I think I haven't figured out.
It's through groups.io. That's what I use. So I can send it though.
Yeah, so for those that don't know, it's just an email address. You send to this group's email address, and it forwards it to everyone.
Yeah. Well, it bounced for me when I.
No, because you replied to a different mailing list. I think if you go to groups.io, that link that I pasted a little bit ago, it's there. If you want to post something, you post to the email address that I am pasting right now. This one.
This one?
Yep.
Yeah.
Oh, I'm not sharing. Am I sharing?
No, you stop sharing, but it's in the chat window, the last message. Yeah. If you send a message to that one, then
this the one?
Go. Yep. Is that the one? Looks that's the one. It bounced back from there.
And so I was on this side, but I don't know if I do message here. Is that the one will take it me?
I don't know. Anyway, sorry. I think we're holding Vilas.
No, I need to drop too. I'm getting pinged to come to my next meeting. Thank you. This was really helpful discussion.
Have a good weekend, everyone. Talk to you
thanks.
next week.
Thanks for good discussion, feedback. Yeah.
Thank you. See y'all later.